Okay, welcome everybody to our course 3 RF LTE UMTS and DAS optimization session 1. This session, this course is sequence of our training program for RF LTE UMTS and DAS cellular networks design and optimization. So we previously successfully delivered our RF LTE UMTS and DAS design course, which contained design across the technologies. uh, Even for DAS, we covered LT and UMTS DAS design using different tools like ATOL and IBWave. It was delivered to the wide range of audiences, and it's still available online, and we have converted that course into an e-learning online platform where you can go take that course from now on your own time, on your own pace, and pretty soon it will be more interactive. You will have question and answers, just any e-learning platform, and it will send you your progress and updates as well. So out of our training program, this is our next training we call it course 3 RF LTE UMTS and DAS optimization. So basically, before I start the introduction to the course and introduction to the and details of the training course, let me introduce myself. Okay, my name is Horam Hussain, and I am myself as I'm an RF engineer in the field of LTE and UMTS and DAS design and optimization for last 11 years. I have worked for different operators, different countries, different vendors. So I have worked if you include the countries, I have worked in Egypt, I have worked in Dubai, I have worked in USA, I have worked in Mexico, I have worked even in Sudan, I have worked in Nigeria, I have worked a bit in Turkey, I have worked in many different places around the world. I have worked for Ericsson Egypt, USA, Mexico. I have worked for operators like AT&T and T-Mobile. I have worked for uh, MTN. So from the third world to the first world. So why? So based on my experience of RF engineering and requirement that this field of engineering, RF engineering, is a very knowledge intensive field, and there are no courses or platform available to deliver that body of knowledge to the willing RF engineers who want to grow or enter into the field of RF engineering. So since there is no platform or courses available, we thought it's a good idea to develop the courses for the RF engineers, so they can, who want to grow in this field, they can come, enter, and grow. So we developed our course structure. We developed we developed our courses. So out of our course organization, this is one of our, we call it course 3, but online delivery with respect to the sequence of delivery, this is the course 2. This is the second course we are delivering. And this course is all about optimization because our first course were all about planning and design of LTE, UMTS, and DAS networks. So this course will cover pre-launch, post-launch, and we'll go into the further details of the course. So before, this is the brief introduction of myself and course before we dive into the detail of index and course details and course outline and roadmap and the basics of RF optimization, which are part of this session. So the way this course will be delivered in 2-hour session each week from now on. This session 1 is a free session for all and we will tell you why it's important for RF optimization and what kind of job market it's available, and we'll introduce the company as well. So let's begin the course itself. Before, yes, this will be recorded, but and the session 1 recording will be available. Yes. Okay. So for us, so this is our course. So what we'll be discussing in this course? We'll be discussing what is introduction to company, which is Mojo Solutions and Services, MSS LLC, which is delivering these courses. We'll get acquainted with the course, who this course is for, and who should attend this course. We'll discuss that. What you should expect out of this course, after you have completed the course. What is the course roadmap, where the course is taking us, RF optimization. So, and then we'll go into the feeling that how this course will deliver you the basic body of knowledge which is required for this course. So let's see, then when we talk about RF optimization, we'll be discussing basics of the RF optimization. We'll see what are call flows, performance counter, radio network parameters. Now, this is just an introduction to all these topics of call flows, performance counters, radio network introduction, key performance indicator, and radio network functionalities. We will just introduce you or give you a feeling of what optimization is about and how optimization is done. The details of all these functionalities, we'll cover all the functionalities, we'll cover all the KPIs, we'll cover all the not all the, but major radio network parameters, but they will come in the later part of the course, not this session. This session will get you a good idea and overview of the job market and how the optimization functionalities work and it's done. So, and the course overview. So these are the 3 objectives. Very good course overview, know the course and understand the basics what this course will be delivering, and if you are ready for this course or not as well. So basics, we are also go through pre-launch and post-launch. We'll just discuss it from high level, but this course contains in detail the complete pre-launch and post-launch process and optimization techniques used, which will be discussed once you decide to join this course completely. So let's go to the introduction of the company. Well, Mojo Solutions and Services, MSS LLC, you can see the logo of the company on the top right. Is a IT and telecom services provider based out of San Francisco, Bay Area, and California. We specialize in recruitments and IT software development. So recruitments is one of the biggest business we have. So why we decided to develop a training program? Why we want people to come and train them? The objective is the field of RF engineering is growing really fast, and there is a big shortage of the trained RF resources. So our objective is to we develop a training program for our employees and fresh and junior RF engineers to gain knowledge and place them on well-paying job opportunities. So we developed this training program to in order to find good resources for our recruitment business, so we can place them once they are trained, and we can get them for the interview. For example, I have at least 35 requisitions for RF engineering jobs right now, but I don't have 35 trained resources. I was only able to place 10 in the last couple of weeks. So there is a big shortage. There are a lot of RF engineers, but trained and who know how to do the job, there is a shortage. And you cannot expect everybody to go and have the experience without training. So this knowledge gap we have to fill, and the way we are filling it by developing this training program which we have. And one of the courses was design courses, which we have delivered. It's e-learning online. And this is the optimization course, which we are delivering right now. So the RF engineering is a very dynamic field. It's a knowledge intensive field, and it is a very vast field, and it has a lot of job opportunities for the right engineers and the right trained resources. So if you are trained, you have a lot of jobs. You cannot be jobless. Not only you cannot be jobless, but you have a very high paying jobs. So if you are a junior level, you can easily get paid between 80 around. But if you are even middle level, you jump to 100 and 120 bracket for a middle level experience, and you can go all the way up to 180,000 or 200,000 dollars annual salary. So, and there are a lot of jobs in the market, but there are not enough trained resources. People try that they put their CVs through different means, not prepare themselves, putting things on the CV which they may have not done. But the thing is, if you whatever you're doing, if you are trained and you go through the interview, and if you're well trained and you pass the interview, even if you have done the training, you are accepted for the job opportunities. Why? Because as long as they can see, because there's such a big shortage in the field of design and optimization, and when it comes to optimization, shortage is even bigger these days. That landing a good job opportunity for a engineer who's trained and have the right knowledge is very easy. Uh, and for that purpose, we have developed this course, so we can transfer you the body of the knowledge for optimization as in a very compared to other short amount of time. If you go through the process of hands-on experience yourself, the same body of knowledge will take you years, whereas this course will deliver you in a matter of 2 to 3 months. So so bottom line is why we have delivered the course, because there's a big market demand, and this is a knowledge intensive field, and the people right now in the market don't have enough experience or knowledge or both in this field. So based on that, this course have been developed to deliver that body of knowledge, which will help you to land into very well paying jobs. So that's the objective behind. But what we do as a company, that's the objective for the company Mojo Solutions Services MSSLC, to design this training program, which contains RF, LTE, UMTS, DAS design and optimization trainings, more than one trainings. So, but as a company, what else we do? We are recruitments. We are in the network testing business. We are in the recruitments business. We provide services of network optimization, network testing, and recruitments and sourcing out consultants. Plus, we are developing IT software and the websites as well for different companies. For ourselves, we have some internal projects going on, which we hope to have a very bright and successful future. But IT is not a part of discussion over here. Whatever we are doing over here is a part of our telecoms division. IT division is something else. It's basically a venture which we are doing. So in telecoms, we place the people, the right candidates. We find them the job opportunities. We prepare them for interview. We do the recruitments. If we have internal project, we hire the people to deliver those optimization and design services. If we have network testing services, based on if we have the post-processing with the network testing and post-processing or only network testing, we provide those services to different companies. Okay. So do we have any questions so far? Please feel free to write the questions. So that is the basic overall introduction to the company. Do you have any questions? You guys can still hear me well? Okay. Why? Yes. Okay, you guys can hear me well still. That's good. Okay, so now let's move on to our next slide, which is introduction to the course. So as I have briefly described already, will those sessions will be recorded to you can watch time. Yes, this all. So the way we deliver these courses is session one is free. Or session after the session one and onwards, we record these sessions. We put them on our website, and the people who subscribe to our courses, they can watch session two and onwards. Our session one usually is freely available on website and even on YouTube. Session one for our course one, which is the RF UMTS LTE design course, is still available on our website and on the YouTube as well. And this session will be uploaded as well. The rest of the session are specifically access limited on our available on website. For design course are still available, and you have to subscribe to get the access to those courses. So this course discusses, teaches, and attempts to deliver complete basic body of RF optimization process, practice, knowledge for optimization of LTE, UMTS, DAS, RF networks. So if you see three words over here, process, practices, and knowledge. So you need to have a knowledge which we'll deliver. We will also tell you the process of optimization and what are the best practices used in the market developed by different vendors and operators like Ericsson and AT&T and different other different companies, or which we have practiced as RF engineers ourselves, or I have practiced myself in the process of pre-launch and post-launch optimization of LTE network or UMTS network or DAS network. And this course covers both RF pre-launch optimization and post-launch optimization for both LTE, UMTS, for all three, in fact, LTE, UMTS, and DAS. There are many similarities when it comes to different technologies. There are many similarities. So the basic body of knowledge is same. We just change the techniques. So what we'll do, we'll go through the basic body of knowledge. How will we go? I'll explain further. Once the knowledge is developed, we'll go through the processes for each of the technologies, and then after that we'll discuss the practices. Okay, but before we we have to structure our knowledge, which is a very important part of this course. Understand what are the basic building blocks of the knowledge, and how should we approach them and understand them, which we will do to as much as possible in the session one as well. So to develop the structure or make you understand the structure of the basic body of knowledge required for RF optimization. No, what we have done basically, we have merged the course 2 and course 3 into course 2 and course 3 into one course. We call it course 3. Okay. So this course covers both RF pre-launch optimization and post-launch optimization. That's the objective. The course and we will cover this course in further detail. We have a complete course restructuring and the website restructuring going on. After the restructuring is done, we are calling it course 3, but as on our current website, this course is course 3, but the same course, this course will be named course 4 after the restructuring of our courses structure. So don't get confused. 2 or 3 weeks down the road, you will see this course, the same course named course 4. So don't get confused then, okay, because we are in the process of restructuring our course program. So what is prerequisites? So before we dive into the course, I should explain you what are the prerequisites and who this course is developed for. So in case you're just a fresh out of a fresh engineer, you don't have any experience, or maybe you don't have exact engineering background and you want to learn, so you may face a lot of difficulties because then you will have to go and attend our course 1 and then come to course 3. So who this course is for? Ideally, this course is for engineers with basic and senior RF design engineering experience. So if you are a design engineer, or have you worked on RFDS or planning tool using tools like ATOL, very good. If you're a drive test engineer with relevant engineering background, it's also very good background, but you should have a engineering background, or you have been doing drive testing for a really long time, or if you're doing the drive test for the short time, then engineering background you should have, or you should go back and take our course 1. So, or anybody who has completed our course 1, RF, UMTS, and LTE DAS design is highly suited for this course as well. So in order for you not to face problems, you should be fitting yourself in one of these criteria in order for you to well understand this course. The thing you can do, you can take our course 1, which is e-learning. You can take it on your own pace and join our course 3. So you can, if you don't have the right background, then you can understand this course very rapidly together. Okay. So do we have any question regarding the prerequisites or the course so far regarding course 3? Any questions? Okay. So this is okay. So let's move to our achievements after this course. You should able to understand optimization process, perform beginner to mid-level optimization tasks, have the ability to understand quickly advanced and complex optimization and performance problems. Okay, so that is what is required, that you have a good knowledge and you should able to quickly understand the complex problems and resolve those problems. So that is the objective of those course. By the end of this course, who are delivering, performing the exercises, reading, taking the quizzes for these courses, understanding and putting their full efforts, they should able to achieve optimization performance, resolve this level of optimization engineering. You should will also able to understand the difference between RF performance and RF optimization. Like there is a difference between there is a thin difference between RF design and RF planning. Okay. So, and once you are able to achieve this objective, this bit understanding and the body of knowledge with the understanding of process, procedures, and the best practices used in the industry, you should able to land yourself, face a very high level of interviews and pass those interviews and land very well-paying jobs. In this process, how will we help? You will attend the course, and our actual business is services and recruitments. Our actual business is not training. The reason we are delivering the training is to support our recruitments business. So the people who have the right background, who pass our internal screening interview, they will be in our database. We will publish, sending their CVs to the clients, trying to schedule their interviews, helping them to develop their CVs, and our recruitment team will be helping them out every step of the way. Okay. So and the reason for being is we are not doing it for free. Why we are doing it? We are doing it to support our recruitment business, which is the biggest part of our actual objective of this exercise of delivering the optimization course. Now let's discuss course roadmap. How will we reach our objective? So as I said, we'll discuss course roadmap, overview, and the basic sense of optimization and building block of optimization during this session 1. So you have a good understanding that how we'll be reaching our objectives. So what is a course roadmap? We plan to achieve basic understanding of RF optimization and performance by understanding the building blocks which execute signal processing, which are in fact call flows, record signal processing, which are basic performance constant and recording like GPH and UTR in UMTS, Ericsson UMTS, and allow us to configure signal processing parameters. What are the parameters? And a result of signal processing regarding create key performance indicator or KPIs in cellular network. So there is in this one sentence, I have tried to put a C inside to capture a C inside it. Basically, what we are doing, we will understand call flows. We'll understand performance counters, what are the performance counters and performance recordings, which are like GPH, UTR, and allow us to configure signal processing parameters, which is radio network parameters. Understand how the radio network parameters affects our performance and are used in the optimization process, and understand the key performance indicators. Okay, so how the radio network works, for how the radio network works in the daily life of an RF engineer who's working for any company, his life revolves around this thing. So RF engineer who is working in optimization, his life revolves around key performance indicators. So his daily work is to find the key performance indicators who are performing bad, find why they are performing bad, fix them by changing parameters, finding troubleshooting, adding capacity. But key performance indicators, he needs a good understanding of key performing indicators, for which he needs to understand call flows, and he needs to understand network functions. Okay, network functions. So what is call flow, what is key performance indicators, what is parameters, what is network functions, we will see in our slides to come. Okay, so what is during this course roadmap, as I said, building blocks. I used the word building blocks of RF optimization. So these are the building blocks of RF optimization. What are these? How the signal processing is done, how the call flows. What is a call flow? What are the example of call flows? What is signal flow? So sometimes we mix up signal flow and call flow, which is similar, but call flow refers to the call. But signal flow or the call flow, we'll understand. We'll understand what are the performance counter and what are the performance recordings, and why do we need recordings when we have performance counters. We will understand what are the parameters, what are the major parameters, and how they are used to optimize. Okay. What are the radio network functionalities, and what are the key performance indicators. So before you can jump to parameters, okay, before you can jump to the parameters, you need to understand what is radio network functionalities and what is call flow. And based on the call flow and the radio network functionalities, how performance counters are recorded. And from those performance counters, how KPIs are created, key performance indicators are created. And to improve those KPIs, how those parameters are changed. Okay. So I'll repeat it once again. This is a very important flow which RF engineering works with. We need to understand first what are the functionalities and call flow. So these are equally important. Once you start to talk about functionality, you start to talk about call flow directly. So we will be studying these two things simultaneously almost. Once the call flow and radio network functionality is done, we need to measure how our network is performing, how that functionality is working. To measure the performance of that functionality, for example, call system success rate, how many calls we attempted, how many succeeded. That's a basic example, and we will take this basic example in this session to understand how different KPIs work. So radio network procedure and functionalities. Okay, so how this functionalities using how the performance is measured for call flow and radio network functionalities to measure the performance counters, to record the performance counters and do the recordings. So recording is separate. We will discuss the recordings in the later part and part of our course. not because you won't be able to understand it in the beginning, but performance counters is very closely related. Whenever we want to measure how our functionality is working, how call setup is working, how drop call is working, how many drop calls we have, we need these performance counters. And once we have performance counters, we need to create KPIs, key performance uh, uh, key performance counters. We have a key performance indicators. Okay, so we have we calculate the key performance indicators. What is key performance indicators? We create performance indicators to tell us what is call setup success rate, or we call it accessibility, retainability, or drop call rate, or handover success rate. So if you some of you have a bit of background in RF engineering, you will be understanding what I'm saying. If you are not, then you will understand. Uh, but we need to discuss further that how will you able to understand. In that case, if you are not understanding call setup success rate or accessibility or call drop or retainability, any of you, if not understanding those words and radio network parameters, he will need to take our course one immediately. So in order to absorb the information in this course. Okay. So basically now let's see how we are trying to deliver the course in this course, our functions. Let me see. So what is the roadmap? So we have a pre-launch part in this course, and the pre-launch part is basically telling you for macro sites and the DAS sites, what is the steps of pre-launch. But we will discuss pre-launch itself, the process, because pre-launch, when you call it pre-launch optimization or the post-launch optimization, it's more about process. You should have the understanding of call flows, call setup, functionalities, KPIs, counters. Once you have those, then when we talk about pre-launch or post-launch, it's process. The way in case of pre-launch, data comes from drive test or data collection tools. For post-launch, the data comes from system counters or performance counters. So at the end of the day, it becomes a matter of process. But what you need to understand is functionalities, counters, KPIs, and how they are calculated. So once we do the counters, when we will be discussing system counters, always remember that system counters are mostly part of the post-launch. But sometimes in pre-launch, we use the system counters to assess the traffic. It depends upon different operators, how the different operators are performing their network pre-launch services. Okay, so then it becomes a matter of process. So once we'll discuss pre-launch and post-launch, it will be about process, like you do the site audits, but what do we see in the site audits? Which parameter do we see? You need to understand the parameters. Single site verification, you need to understand what are the parameters of single site verification. Cluster optimization, so you will need to understand what are the important, what are the tills, what is electrical, what is the role of electrical till, mechanical till, admission control parameter, congestion control parameter, what is the gold standard. Okay, what is to understand KPI thresholds, you need to understand the KPIs itself first. Okay, to have a report analysis, you need to know what is pilot pollution, what is multi-server, all those concepts. Okay, so this all pre-launch and the post-launch both. So this is the pre-launch slide. The next slide is the post-launch slide. We'll discuss in this course, but in the later part. But once you have the basic body of the knowledge, then we'll able to discuss those things. Okay. So similarly, there is a slide for post-launch. You can go and see on the course 3 post-launch. You'll able to see the slide. As I said, we have merged our course 2 and course 3 into one course. Okay, but again, pre-launch and post-launch is matter of process and procedures and the best practices which we will discuss later part of the course. We need to deliver the body of the knowledge and understanding how these are implemented in the pre-launch process and the post-launch process. And the pre-launch and post-launch process for different operators like T-Mobile and AT&T is different. than Verizon. So this is a matter of process. Every operator have different pre-launch process. Post-launch process, it cannot be different, but they have different tools to analyze post-launch KPIs, change the parameter, and they follow different best practices according to their experiences and network dimensioning. So we will discuss those in the later part of this course. Okay. So what we identified as the basic building blocks for this so far, for which we need to understand the develop the understanding. These are the four things. So once we develop the understanding for these four things: call flow, network, radio network procedure and functionalities, performance counters and recordings, and radio network parameters, and how those parameter changes are done. So then what we'll able to do, we will able to understand what is pre-launch and post-launch and how different operators are doing different things. So the unknown factor will be out, and whenever you go, you will say, okay, it's just a matter of process which they are following. This can be done this way as well. Different operators do different ways. In the US, things are very procedure and process oriented. Okay, so everything is done according to the process and procedures, and different companies and operators and vendors have different procedures and processes which you have to follow. But if you go outside USA, there are many third world countries where the process and procedures you have to develop your own for your own daily routine. So in that case, you need those most. When you come to US, there's a process. They deliver you the process. They ask you the question about the process during the interview. If you have the basic body of knowledge, they test that you have the knowledge, because if you have the knowledge, you will be able to understand their process. If you don't have the knowledge, you will not able to. Okay, so that's how basically the flow of interview goes. They talk more about the process and procedures than the tell me the call flow. So you will rarely being asked the question about the call flow, but he will ask you a question about the process which will be related to call flow, and then when you will start answering, he will cross question you, or you will have to explain yourself the call flow for particular setup or particular signaling flow or particular performance counter, particular KPI. But even during the interview, everything goes by the procedure, that what you have done and how you have done it. Okay, and that you cannot do satisfactorily unless until you understand the basic building blocks of RF optimization, which these are the four building blocks. Now, wherever you go, there's no course in the world which will develop you which will tell you what are the building blocks for optimization and deliver you, and in order to deliver the process and best practices. So this comes with if you have a multi-operator and multi-company work experience, then you start to see how the things are working in the field. So what is RF optimization? In this, what is next? What are the radio network functionality? Okay, so we need to understand there are a lot of radio network functionalities, few basics, few advanced. For example, call setup is a radio network functionality. Handover is a radio network functionality. Cell selection and reselection, or which is also called idle mode behavior of the UE, is also a radio network functionality. Directed retries and radio network functionality. CS fallback for LTE only is also a radio network functionality. Okay, so in this course, one thing I said: call setup, handover, cell reselection. With call setup, I did not mention LTE or UMTS. Cell selection, reselection, I did not mention LTE or UMTS. Directed retry, I did not mention LTE, UMTS, because these functionalities exist in both UMTS and LTE. Their signaling flow is different. Their basic jargon may be different, but they exist in both LTE and UMTS. Okay, but when I talked about CS fallback, it's a LTE specific functionality. So I put it's a LTE function only. So once we will discuss separately for UMTS and LTE, and based on the similarities, we will very quickly understand that okay, LTE works like this, UMTS works like this, and how, because LTE and UMTS are very similar when it comes to the signaling flow and the KPI calculations. The only biggest difference between LTE and UMTS, can somebody explain me what is the biggest difference between LTE and UMTS in terms of radio network functionalities? Can somebody explain me? No. Okay. The biggest difference is circuit switch. Yeah, you're right. It's LTE is all IP. It's LTE is all IP. There's no circuit switch calls. The voice call even in the LTE is IP call. It's called VoLTE, voice over LTE, or it's a IP call. Even the video calls are CS calls, CS64 calls. In UMTS, video calls are CS64 calls. Voice call is a circuit switch call. Okay. In LTE, that's not the case. Everything is IP. Okay. Complete air interface. Of course, air interface is different, but with respect to radio network functionalities, uh, I said radio network functionalities. I did not say air interface. Of course, air interface is completely different for LTE and UMTS. There's a big difference in the air interface of LTE and UMTS. But with respect to functionalities, the biggest difference is LTE does not have any circuit switch functionality. It's all IP, and UMTS has both circuit switched and packet switched, and it has two different flavor of packet switch, which is R99 and HSPA. Okay. So, and we discussed these HSPA and R99 in detail in our course 1. If you have attended our course 1 or you have worked on these technologies, you will be able to easily understand what I'm saying. Otherwise, maybe you have difficulty in understanding the what I'm trying to discuss over here. The list of radio network functionalities are long and will be discussed during this course. So there is not one functionality. There's RRC setup. There's congestion control. There's a cell load sharing. There is a interfrequency handover. Okay, so there are long idle mode behavior. Idle mode behavior, cell selection and reselection. These two things are the part of idle mode behavior. Okay, so all these things basically are our radio network functionalities, and there is a long list. So during this course, we'll go about almost all the radio network functionality. Right now, I will take you to the one radio network functionality, because remember what I said. I said one thing very important. Note it down. I said everything, number one, surrounds around radio network functionality. Radio network functionality determines what is the call flow. Okay, the call flow is standard call procedures according to 3GPP standards. Okay, so what is the actual call flow, and if there is a failure in that call flow, how do we measure? If there is a call flow, there is a call failure, how do we measure? We measure using performance counters. Okay, so we measure using performance counters. So what are performance counter? How many types of performance counters are there? And using these performance counter, we create key performance indicator for our daily operations. How these KPIs, key performance indicators, are created, we need to understand. But how these performance counters are recorded, we need to understand it based on the call flow. So we need to study the radio network functionality. What is the call flow of that radio network functionality? What is the performance counter, and how those performance counters are translated into KPIs. The other part of the puzzle is, if the KPI is bad, how do we optimize the KPI? Okay. So we will not able to reach that part. It's in this session 1, but of course, during the course, session 2 and other sessions, we'll be discussing how to optimize. So if the KPI is bad, how to optimize? If this is bad, what are the scenarios? Or how was it optimized in different cases when there is a traffic is high, or the coverage is bad, or interference is high, external interference is there, internal interference is there, all those scenarios which are there, which we'll be discussing in this course. Okay, so you by this time you should able to understand one thing. You should able to understand that one thing which is important for this field is knowledge. Okay, so before we dive into further, let's go to the basic architecture of UMTS and LTE. You guys should already know it, but this is only for the overview over here. So in LTE, we have UE, which is connected with our air interface to our eNode Bs. So the interface between is called UU. eNode Bs can communicate between themselves. The neighboring eNode Bs are connected using X2 link, and they are connected with the MME, which is mobile management entity. What is MME? What is the architecture? I expect that you already know that, okay, in this course. If you don't know, the course one is the course you should go through or study it somewhere else. But what is MME? What is the function of MME? MME handles the mobility. I will not go into further detail because I don't want to prolong this course. It handles the mobility, okay, mobility. So if you guys have attended my course 1, you should remember I explained to you guys that we have a RNC in UMTS. The RNC has 3 functions of traffic control, mobility, and integrity, call integrity, that the call remains connected and the quality of service is good. These were the 3 functions of RNC, major functions of RNC. But in LTE, out of these 3 functions, one function, mobility, is in MME. Rest of the functions have been embedded inside the node B. Okay. So can you guys see my pointer? Yes or no? You guys can see my pointer, correct? Okay, so that's good. So if you can, embedded. So if you want to know the detail what I'm talking about, go to the session 1. Session 1 is freely available on the YouTube and on our website as well. So you can understand the architecture. I won't repeat it over here. I have explained the architecture in detail. Okay. So, but remember this S1 is very important because, and S1U is for the traffic. S1 MME is for the mobility signaling. For UMTS, we have IUB, you have IU interface, CS, and IUPS. IUPS goes towards the packet core SGSN, IUCS, and these are very important links because they determine the call setup and other features. If you want the detail of this, go to the session 1 of the course 1. That will help you out a lot. Okay, so we understand so far what is the basic. We have developed the basic understanding of the architecture knowledge. Now let's go towards feel how the call flow interacts with radio network functionality interacts with call flow, and the call flow helps to create or record counters, and the counters translates into the KPIs. Okay, so let's take a one functionality. Okay, it's a very big functionality in itself. Okay, handover is a functionality, paging is a functionality, LAC or TAC updates is a functionality, RRC establishment is a functionality. So one call setup procedure is a super functionality. Okay, the rest of the functionality like RRC setup is one of the subset of the functionality. How will we understand? Let's go through this call flow. Okay, so the functionality is call setup. So when we establish a call, that's a functionality of the radio network to establish your call. That's one functionality. Okay, so how do we do that functionality? Simple. When you make a call, the call goes to the network and call is established. In simple layman words, that's a functionality. But how that functionality works, we need to understand the call flow in that case. So how that functionality works basically? We know that we have, this is a call flow for LTE call setup. Okay, so we have node entities, UE, which is our mobile phone, eNode B, MME, and SGW. Okay, so based on our service request, few things are very important. We have a RACH process. Okay, what is RACH? RACH is a functionality. Okay, so what I have selected over here, I have selected a bigger functionality. which has a lot of subset of functionalities. Okay, so RACH setup is a subset functionality, which is called random access setup. In this course, we will discuss RACH, its preambles, parameters, how it's recorded, how it affects our network performance, how the KPIs are recorded. So how the RRC connection request is another sub-functionality. So for this example, this is an example. This is not a complete deliverable for the complete course. But for this example, I have selected a very vast functionality, which is called setup. It has sub-functionalities, which is RACH, RRC, and authentication and RRC connection reconfiguration. Okay. So I will explain you what is RACH setup and how the system information works in basic understanding of all those things. We will have a topic or complete discussion on system information itself. We'll have I believe, random access and RRC connection setup and functionalities will take a whole session to explain. Okay. So we will be discussing all those. But over here, I'm trying to get you the understanding of basic how the call setup, what is the call flow functionalities, and how are these sub functionalities are there, and how they are translated into counters and the counters into the KPIs. So this is our functionality. This is system information. So what is system information basically? So system information. So UE reads system information, broadcasts in cell, and performs uplink and downlink synchronization. If you turn on UE, how will UE know which frequency to synchronize? How will UE know which neighbor to hand over? How will UE know if it's an idle mode, at what level the signal goes off, and at what level I should make a call? If the signal level is too bad, should I make a call? Does the network allow me to make a call at a signal level RSRP of -118? Does the network allow me to do that? If you don't understand RSRP, trust me, you will not be able to understand this course. Or you don't understand RSCP, it will be very difficult for you to understand this course. So I will advise you to go and jump to the course 1 as soon as possible. At least go through the session 1, which is free for the course 1, and then decide to take on the later course sessions or not. But if I'm saying RSRP, RSCP, and you're not understanding that, because optimization is an advanced level course, it's not a beginner's level course at all. You need a basic body of knowledge, not advanced level of knowledge, but basic body of cellular network knowledge. So I'm repeating once again from the prerequisites what we discussed. You may not be able to understand it because RSRP, RSCP, then it's difficult for you to go through this course. Jump to the course 1, do a crash program of course 1, subscribe to course 1, complete the course 1 crash program, finish the course 1, join the course, this course 3. So it's up to you. But I'm confident that many of the guys who are here, they will be understanding it very well if they have worked in the field already, at least as a design or type test or basic post-processing engineer. Okay, so we have the functionality, system information. So system information, we will not go into the detail over here, but what is system information? It allows the UE to synchronize with the network, know when to make call, how to synchronize, which frequency to read, and which frequency to make call on. Okay, so once it is synchronized, once you make a call, when you push a call button in LTE or UMTS, or make a data connection, there's a random access preamble. So random access is a procedure which is there from the GSM, and it will remain there as long as the radio networks are there. So whenever you make a call, you have a random access process. Random access has a preamble which it sets to the network, and the objective of random access is to give you a control channel. Control channel in order to establish a traffic channel. Which is traffic channel. What is a traffic channel? It is a call. So the random access channel will give you the control channel. The control channel is called radio resource control connection. Radio resource request will go. Radio resource connection request will come. Or will be granted. Over here it should be say radio resource connection reject or granted. And as a result, if it's a request granted, it is RRC connection setup complete. And initial UE message, the node B tells that I have given RRC to this user, and this user is no more in idle mode. Once you have a RRC, radio resource connection, you move from idle mode to the dedicated mode. So what is idle mode? What is dedicated mode? We will discuss, but if you have been working or you have taken course 1, you will already know what is idle mode and what is dedicated mode. Okay, so then initial UE, once the authentication is done, the RAB is established, modified radio access bearer. So our objective is RAB. So the traffic channel in LTE is called ERAB. What is it called? ERAB, enhanced radio access bearer. In UMTS is called RAB. Okay, the signaling flow, if I pull up the chart for the call setup, call flow, it will be very similar to that, except that instead of MME, here will be RNC, and RRC request is granted by the RNC. So this signal, I told you the functionality is taken over by node B. So instead of node B, the RRC connection request will go to the RNC. If RNC is written over here, it will go to the, so for example, in case of UMTS, so let's talk about UMTS. Okay, there will be RNC, and over here RRC connection is functionality, because I told you traffic control, integrity, and mobility. So traffic control and integrity, both in case of UMTS was with RNC. So this signal will go to the RNC. Okay, and this request will come back from the RNC. And the RRC connection setup complete request will go to the RNC. Okay, so that will be the difference. That will be the biggest difference you will see. Okay, rest will be a lot more similar when you see the call setup flow for UMTS. Okay, but since the functionalities of traffic control and integrity are in case of LTE is embedded in the node B, we have RRC connection request going to here, and most of the functionality is being performed by the node B. Okay, so what was in our call flow? The system information came, the RRC setup or the control channel. The control channel tells the control information of which frequency, how much data, request, node B. So it is forward to, once the RRC is granted by the node B, it is a complete node B function to assign control channel in case of LTE. Then forwards to NAS service request. So what is NAS? NAS is non-access stratum. It's a complex, it's a fancy word. Okay, non-access stratum. Okay, it's a fancy word. What is it? Any signal which is going from UE to the MME or node B, it is called non-access stratum signal. So it's just a fancy word. What it tells you exactly, basically, it simply is non-access stratum signal. It basically tells you any signal which has been going to the core network from the UE, from here directly to here. Any message which UE sends to MME or SGW, or SGW and MME sends to UE, and eNode B, job of eNode B is to pass that information, is called non-access stratum. That's it. It's just a fancy word. I hope that concept is understood. So once RACH is established, RRC is granted. So objective of random access is to get RRC. The objective of RRC is to get RAB or bearer or access bearer, which is a traffic channel. Once traffic channel is established, SGW and MME sends SGW a request that, okay, I have the, we have established the channel, the traffic is established, you can send the data to the UE directly, or UE can request the data directly from the SGW. Okay, so is that understood? Is there any confusion in this call flow so far? Okay, if you have any issue with the call flow, you can raise your hands. I'm watching right now. You can raise your hand and I can unmute you and you can ask the questions. Okay, You can ask the question later part as well. You can write the question and I'll try to understand reply them. So basically, once the call flow, system information and call flow is done, what is system information? I have given the basic information of system information and call flow. Once basically, as I explained, the RAG preamble, power of the RAG channel, all those things are communicated in the system information, and objective of RAG is to get the RRC, and RRC is to get the RAB. We will discuss all those concepts in very much detail in this slide. Okay, so we have to establish a call. Okay, so establishing a call is a call setup. Okay, or it's called accessibility. Okay, so call setup or accessibility is the two names of the same concept. Okay, we have to establish a call, we have to set up a call, or what is our accessibility, or what is our accessibility process. It's the same concept. It's two words for the same thing, call setup or accessibility. Okay, so if I say what is the call setup success rate and what is the accessibility percentage, it's the same thing. There are same formulas for that, exactly the same thing. There's no difference, because operators over here use this word, rest of the world use still most of this word. Okay, but few major operators over here use accessibility, but these are the same thing. These two are same concept. Even formulas, you will see different operators will have the same formulas for the KPIs for accessibility. But in order to understand the functionality of call setup, so still we are working on the functionality. Functionality is linked with the call flow. Okay, functionality is linked with the call flow. So we went through the call flow. We saw the call flow, but we need to identify what are the major components of this call flow. Okay, what are the major components of this call flow? Okay, so if we see this diagram, the major components of this call flow can be 4. Random access, RRC setup, S1 signaling setup, ERAB establishment. Okay, so few things are very obvious in that diagram. Few things we will understand later. So I said random access. Okay, this is the part of random access, which leads to objective of random access is RRC setup. Okay, RRC setup needs S1 signaling establishment. S1 signaling, S1 is the signal, S1 is the interface between core network. S1 has two parts, S1 MME and S1 it's called traffic or S1U. So S1 MME goes to MME and S1U goes to SGW. So we have to establish S1 signaling. Once S1 signaling is established, then the RAB is established. The radio bearer is established, which is in case of LTE, this is different, radio bearer modification. They call it radio bearer modification because LTE has a concept. What is that concept? That even if your UE is in idle mode, it has a bearer. Okay, it has a bearer which has no quality of service, which has no throughput, nothing. But if your phone is on LTE network and it is not making any calls, it's just connected with the network in idle mode, it has a bearer. That's the concept of LTE with zero throughput. And once you make a call, that bearer is modified. That bearer is modified to some throughput value, like it has a throughput of 2 kbps, some service, some quality of service or something. So that traffic channel, so even if you're not connected, theoretically in LTE, you have a traffic channel or you have a bearer. That bearer does not have a traffic channel because there is no traffic. But once you have a traffic, you make a request or the call comes to you or data request comes to you, you will convert that bearer which has a zero throughput to you will modify that bearer, and you will modify that bearer. So you will send a modified bearer request, but to send the modified bearer request, why will you send? To get ERAB, to establish ERAB. Okay, ERAB is already there. So you have just modified the ERAB, but you modified the ERAB by taking traffic channel on the air interface. So before that, you did not had any traffic channel on the air interface when you were in idle. But when the random access was done, RRC was established, S1, this is all is the part of S1 signaling. S1 signaling. Okay, this is all S1 signaling. That's what I'm saying. ERAB theoretically is not dedicated mode only. So you have a RAB established, you have a ERAB established even in idle mode, but its throughput is 0, but you don't have any traffic channel. The ERAB traffic channel to the ERAB comes, or the air interface resources are dedicated only when you have a throughput. In case of LTE, you have a IP assigned. You are always connected to SGW. Okay, you have a bearer or the RAB established that has a 0 throughput. Okay, so on the logical level, there is always a ERAB. There is always a bearer in LTE. In case of UMTS, that is not the case, but in case of LTE, that is the case. On the logical level, there is always a bearer. Okay, you have a assigned IP address. You always have a assigned IP address on your phone, but you don't have any traffic channel. You don't have any air interface resources. Once you establish a call, it goes through the random access RRC, and RRC converts into the S1 signaling. Once S1 signaling is established, RRC reconfiguration changes from establishment to traffic, and then you have a theoretical bearer, which I told, which is a logical bearer. That logical bearer converts into gets a physical traffic channel, so you can say it becomes a physical bearer. It's a very important concept. Sometimes it's asked during the interviews as well. Okay. Okay. So this is the concept. So let's go and so this is the concept. So do you have any confusion about this concept? So okay, RRC connection reconfiguration is basically once you have changed from call setup, the call setup has been established. Okay, the call setup is done. So you need to reconfigure your control channel according to to control the ERAB. So now this ERAB is not, now this RRC is not there to establish a call, because the call has been established already. Bearer modify requests have been sent. So this RRC reconfigured itself and to control the traffic part of this channel. So it's just the change in the RRC. Objective of the RRC has changed. Before it was used to establish the traffic channel. Now it is used for the control of the signaling. That's it. Okay, so that's why this reconfiguration signal is there. And this reconfiguration will be done once the S1 signaling completion has been done. So we understand these are 4 steps. Okay, so random access is successful. Result of a successful random access will be RRC setup. Successful RRC will result in S1 signaling. Between these two processes, once RRC has been set up and ERAB modification request has been sent, which is basically theoretically, practically it is ERAB request. But since in LTE there is a logic on the logical level, there is a ERAB always established with a UE, even if the UE is in the idle mode. That's why we have ERAB establishment. So it's in idle mode, it has a ERAB establishment. Okay. So between these, there is a RRC reconfiguration. Okay. And this RRC reconfiguration is done to control RAB, and after the RRC reconfiguration and modification requests have been sent, we have a ERAB established. Now, these 4 major processes are also present here. So I believe picture should be more clear to you guys, because this is very important. Picture should be more clear to you guys. Step 1, random access. Step 2, RRC. Step 3, S1 signaling. Step 4, basically I will include this RRC reconfiguration in step 4 as well. So 1, 2, 3, 4. Okay, that's how it's translated. Okay, so if you see, this is how these 4 steps are translated. These 4 steps are translated. So call setup process should be clear. What are the major steps? What are the major signaling? Now, as I said, call setup is a superset. Within the RRC connection setup, there are many signal establishment, many requests and many kind of information exchange. Same goes for S1. Over here in this, it is explained in the broader term to make it easy. But let's say if the RRC setup fails, okay, RRC attempt fails for any reason. I'm not discussing the reason. I'm just discussing the failure. What will happen? If RRC connection setup request was sent and it was rejected. Okay, it was rejected or request was sent, but no response from the eNode B was received. No response was received because once the RRC connection request is sent, UE waits for certain time. That time is a parameter which is fixed. Usually that time is 8 seconds as far as I can remember. These are different values. That's called UE timer. We will study that in the later part of optimization. After that timer expires, UE assumes that it is rejected, or if the rejection comes from the network. In either cases, if the 8 second passes, if that particular duration, I'm just assuming it is 8 seconds. When we'll go to the optimization part, we will discuss the exact number. But if that timer expires, or the eNode B says RRC connection reject, okay, both cases it will reject, right? Now the importance of counters comes in. Okay, when it is rejected by the eNode B need to record. eNode B has a table. Okay, I had received RRC connection request. Okay, I received one connection request and I granted RRC success, one success. I received 2 requests, I granted 2 success. I received 100 requests, but I granted 97 RRC setups. So what is the RRC setup success rate? eNode B received 100 requests and granted 97. So what is the RRC setup success rate? Okay. But what is the RRC setup success rate? Wake up, guys. 97%. Simple as that. Okay. So it is 97%. So, but node B or the network needs to record it somewhere. So that records are created using counters. Okay. Or performance counters. Performance counters. Okay. Same goes for RAB. So once the RAB reconfiguration request is sent and the RAB reconfiguration is granted, okay, so that is for RAB request. So if request is sent and there is no RAB granted, then we'll have a RAB failure. So okay, so RAB failure. So we can identify two important things. So we have 4 important things we have identified for call setup. Okay, we have identified 4 important things in call setup. These are the random access. If random access fails, we will not reach RAB establishment. If RRC fails, we will not reach there. If S1 signaling fails, we will not reach there. So what we do, call setup success rate or accessibility as it called is a product of. Product means mathematical multiplication of all these 3. This one is not included. Why it's not included? There is a complete reason, logical reason for that. I will explain you that. But if call setup represents success of all these, if the call setup success rate is 100% or accessibility is 100%, it means all these 3 setups have successfully passed. Okay. Now, how they are recorded? As I explained, they are recorded using performance counters, right? And that performance counters translate into KPIs. So we understand that at each level we have different performance counters. For random access level we have different performance counters. RRC setup success level we have different counters. S1 signaling setup level we have different counters. ERAB establishment we have different counters. And once we want to see what was our call setup success rate or accessibility, we calculate this and multiply this, all these three. Okay, why don't we multiply this? That will be explained when we will discuss random access functionality in our other sessions. Okay, so these three, so this is very important concept. So is that clear to for your guys so far? Okay, so that's how. So what is random access? Synchronizing with the network. I will not go into the detail because we will discuss in detail how the success rate of random access is calculated using these two counters. PM, this is for Ericsson. This is example for Ericsson counters. Every vendor have different counters. This is for Ericsson. Ericsson uses PMR random access attempt CBRA and random access CBRA random access. So once you divide this by this, multiply by 100, you get the success rate for random access. Okay, but when we calculate the call setup success rate, random access is not part of the call setup success rate. Why? We will explain it later, but it's not the part. But RRC is the part of overall call setup success rate or accessibility. Okay, once this is established, RRC, what are the counters? These are the counters which affect RRC. Okay, these are the counters which affect RRC. What are these counters? How they work? We will discuss in detail in our sessions to come. In simple words, RRC, this is establishment success rate. This is RRC attempt. We divide success by establishment, multiply by 100. We get RRC success rate. Okay. RRC attempt directed retry attempts. These are the examples. These are RRC connections establishment due to the call attempts and due to some other reason because of IMSI update, location update. So this is the counter which RRC requests due to other reasons. Okay, due to location update. But for call attempts reasons, these are the two counters which we use to calculate RRC connection. So in order to calculate call setup success rate KPI, we need other performance KPIs. We don't call them KPIs, we call them performance indicators. So this is one of the performance indicators. We divide this by this, multiply by 100. This is one of the performance indicators. I will call it PI. It's not key performance indicator. It's a performance indicators, and it helps us to create a key performance indicator which is called accessibility or call setup success rate. Okay, so RRC connection success rate, we calculate it using RRC connection setup counters. What are these two counters? These are the two counters. Okay, we will once again discuss them in detail. I'm trying to give you the feeling of how the counters are calculated. So once again, I told you that this is a superset. This is a superset. This is a very wide example. If I go into the detail, this is one of the example, that subset. How is the random access response is established? How the RRC connection request is done? That's how it is done. That's how it is done. Okay. So in the previous diagram, it was a high level view, as I said, but over here, how the random access is established, because this is the part of random action RACH functionality. So when will we discuss RACH functionality? We'll discuss in detail that what is the role of RA, RNTI, what does it mean, what is the preamble, how it's set up, what are the parameters, in DAS what is its role, in macrosites what is its role, okay, and once the RRC is established, how it's acknowledged, all those things will be discussed. But that was a bigger picture. That is the close zoom in for this, okay, and how this RACH is calculated and how the RACH KPI is calculated. Okay, so I can assure you one thing: after attending this course, you will know the optimization, how to do it hands-on on the job. Okay, So now the step 3, RACH, RRC, the 3 was S1 signaling. S1 signaling is basically the signaling between E node B and the MME. Okay. So if there is a failure, like MME says I'm loaded, MME rejects it, the signal does not reach S1, the transmission link fluctuates, whatever happens, the S1 signaling has to go through successfully in order for the call setup to be successful or the accessibility to be 100%. Okay. What is the authentication? Why is the authentication done? Because when we set up a call, network has to identify you every time based on your IMEI. So the authentication has to be done. Then there is a security message. Why? Network needs to know that IMZ which has been sent is sent by the legitimate UE. There is no hacker is trying to emit the IMZ of some user in order to gain the access to the account of the user. Okay, this is very possible. Okay, so that's why the security protocol is there, which authenticates the security key based on the IMZ. Okay, so there are a lot of security procedures done. So as a result, what is the result for RF engineer? Yeah, it depends, IMZ or TIMZ. It can be based on either of them. Okay. Usually after IMZ, TIMZ is assigned, and the signaling is based on security signaling based on TIMZ. But if you have just turned on your mobile and you start to make a call, then most probably it will be on IMZ, because TIMZ assignment takes some time, depending. We'll discuss all those signaling procedures later on. Okay. So this is done. So S1 signaling. So in short, S1 signaling has to be successful. What are the details of S1 signaling? These are the details of S1 signaling, which we will discuss in our sessions to come. Okay. So how are we measuring? So now you have a feeling that there is a functionality. RRC setup is itself a functionality. S1 signaling connection establishment is a functionality, and every functionality has a call flow, and every functionality has to be measured. And when it has to be measured, it has a signaling counters. So counters, when it comes to counters, it's not so difficult as long as it's peg counter. Okay, as long as it's peg counter. Peg counter are very simple. You receive a request, attempt, it will increase by 1. Success, it will increase by 1. Okay. So it will keep increasing by 1 by 1. Okay. So that's how the peg counter increase. So you want to know the signaling for S1 establishment. So we remember call setup is a process of random success rate, RACH success rate, RRC success rate, S1 success rate, and RAP success rate. 4. In the KPI of the call setup success rate, we include 3 things: S1 signaling success rate, RRC success rate, and ERAP success rate. So we know how to calculate RRC success rate. We are learning that it's so simple in Ericsson. Success divided by attempt multiplied by 100. We will get the S1 signaling success rate. Okay, which is important for us to get what? Call setup success rate. Okay, so we will see that. So now what are the components as signaling? RRC connection setup is complete. What are the components? These are the 2 major components. Okay, we will discuss it once more in detail in our next session. S1 signaling attempt, when is this counter is pegged? You see this mark, it tells you that when the signaling is done, this is pegged. When it comes back, so at this stage, this success counters come back when the MME tells, okay, S1 signaling is successful. MME is telling this to who? It's not telling it to UE. It's not telling it to UE. It's telling to node B. It's telling it to E node B. Okay. And how we are calculating S1 signaling success? Divide this by divide this. But what is our whole objective? Our objective is to calculate accessibility or call setup success rate. As I said, accessibility or call setup success rate are the same name of 2 things. Same 2 names of the same thing. Sorry. Okay. So we were able to understand how it's done, okay, and how it's established, and we know how the counters are being pegged. Okay, so we have the 4 stages. We understand 3 stages. The last stage is what? Can you name me the last stage of call setup success rate? What is the last stage of call setup success rate calculation? ERAB, exactly, ERAB success rate. So we will see the ERAB. So okay, so ERAB has these signals. Okay, MME sends initial request, node B security mode, UE. As RF engineers, you have one counter. Okay, okay, so you have one counter, performance counter establishing all things. What is that counter? ERAB attempts, and ERAB success. Okay, so the procedure is so long, it has so many steps, but what is the input? Attempt. What is the output? Success or failure? Success or failure. Okay, so if attempts are 100 and successes are 23, it means you have a 23%. So if for example our ERAB is failing, okay, and we want to know why it's failing, then we'll check congestion, reconfiguration, everything. But if we are not able to know why it's failing, then we will have to study one of these messages. How will we study one of these messages? Can anybody tell me how we? Because ERAB we are studying using counters. ERAB attempt, success. Attempt, how much we did. Success, how much we succeeded, how much we failed. But in case we failed, how we failed, what stage we failed, why we failed. Okay, this is a big question. This is always a big question. Maybe we failed during initial contact setup success request. The request which was sent by the UE. If we, let's go to the next slide. This slide. Okay, ERAB establishment. Okay, so the request which was sent by the node B to the UE, maybe it was not received. Signal fluctuation, anything. This is the S1 link is S1 MME link is intermittent. The transmission is fluctuating. This link was congested, whatever. Okay, so the authentication security mode procedure maybe failed. This failed. This failed. This failed. Any one of this procedure failed, this ERAB establishment will fail. And once ERAB establishment fails, call setup success rate or accessibility will fail. Okay, so as a RF engineer, when you are using call CSSR, okay, call setup success rate or accessibility, you see where it is failing. It is failing on RRC, it is failing on RAB, ERAB. Okay, is it failing on S1? Okay, but out of these 3 things, RACH is not the part of this calculation. Okay, so this is a tricky part which will be studied during optimization. Like if RACH is failing, we will never know, because this KPI is not taking into the account the RACH success. So the RACH success is not part of this KPI. Why? We will learn it later. And if RACH is failing, the user is not able to connect, and we are not able to know. Why we are not able to know? Because our KPI, call setup success rate or accessibility, is not taking into the account RACH. Why it's not taking into the account is a different subject. I will discuss it later in the other session. But it's not taking into the account RACH, and we are not able to know. So how we know RACH is being established well and the RACH success rate is full? We have a process for that. We have a KPI for that. We have a testing procedures for pre-launch for that, and we will be discussing those in details in our sessions to come. Okay. So we had 4 steps. You remember? We had 4 steps to establish a call setup success rate. You remember? RACH is not part of the KPI, CSSR or accessibility. This is accessibility. Okay. So this is 2, this is 3 and 4. RACH is not included. Why it's not included? We'll next session probably that will be our topic. Okay. So RRC connection success rate divided by attempts minus Z temporary minus attempts due to other lack update, other updates. Okay. So the attempts due to which the for example, RRC is established when you make a call, but RRC is also established when the location update is done. So if you guys don't know what is location update or tag update in UMTS, you need to go and study it. Okay, so after the tag update timer expires after 4 hours, after 4 hours or 3 hours, whatever the network has said, there will be a request by the UE to update the tag from the network. Okay, so that request, that attempt for RRC is not because of call establishment, it's because of signaling. Okay, so when we are calculating our KPI, we should remove that attempt from our overall attempts in order to have right value of the KPI. That's why that signaling RRC request, which is done by the UE and the network time to time without your intervention, without you establishing a call, without you making a data call or voice call, that needs to be detected. So that's what is detected from here for signaling other than user interface signaling. That this is the RRC success rate. Okay, success rate. This is S1 signaling success rate, and this is ERAP signaling success rate. So I told you guys it's a product of these three, and that's how our accessibility or call setup success rate is calculated. You guys, I will go back to the slide where all this story started, and this was the story where we started from, basically from this slide. Okay, we said call setup depends on these 4 factors. Our KPI, which is accessibility KPIs, takes into account these 3 factors. This 4th factor is not taken into account. Why? When we study random access network, random access functionality, we'll discuss that, why it's not taken into account. These are the 3 functionalities. Based on that, we have a signaling, we have signaling procedure, we successful signaling, how the counters are calculated, how the call flow is done, how the counters are tagged, and how the KPI is out of those counters, how the KPI is being calculated overall, like this KPI. Okay, so this is a KPI formula for call setup. So similarly, we have a call handover success rate, data retainability. VoLTE has voice retainability separate, data retainability separate, data accessibility separate, data retainability separate, voice accessibility, voice retainability, handover success rate, throughputs, troubleshooting for throughputs, low throughputs, latencies, what are the factors for latencies. All those things will be discussed in this course. This is one of the examples of call establishment success rate, which we have discussed over here. And this is what this call setup radio network functionality, which is call setup functionality, is a very big functionality. It has subsets, which is RRC setup, RACH setup, RACH radio network functionality, RRC radio network functionality, S1 signal establishment radio network functionality, ERAP establishment radio network functionality. In order for a successful call to set up, all these functionalities should work, all these 4 functionalities should work, and then we can calculate the KPI based on that. That was the overview which we did from top to the bottom for example of accessibility or call setup success rate in this. So basic, I gave you a long example of call setup success rate or accessibility. So basic building blocks again are for us radio network functionality, which is broader or tightly linked with call flow. And as soon as we want to measure how our radio network functionalities, different functionalities, call setup, RACH, RRC, RACH, RRC are individual functionalities. They make a bigger functionality called call setup functionality. Similarly, drop call is a functionality. Okay, so once the RAB is established, handover is there, pollutions are there. So based on the handover, IRAT handover is there. Based on all those functionalities, we calculate retainability. Once the retainability is there, how the retainability is calculated, retainability or drop call. It's the same name of 2 different things, different way of look at the things. Okay, drop call is calculated or the retainability is calculated, and how it's pegged we will study in the session to come. And once we find the issues with our call setup success rate is low, how to change the parameters, what can be the causes, how to troubleshoot it, what parameters are maybe affecting our call setup, how to change the parameters,
what more let's say in case of Ericsson, we will emphasize on Ericsson in this course. So what are the Mojosol MOS commands or Mojosol commands to change those parameters? How to retrieve those parameters from MOS? Sorry, and all those things we will be discussing in this course, which will be coming. So this is basically overview of telling us that in all basic building blocks of RF optimization HUD is these 4 parameters, and all these 4 are measured using key performance indicators. We took an example of call setup success rate and accessibility for these key performance indicators and how it's used and how it completes how it completes our overall process. Okay, so this is the basic overview for our first session. We have completed our first session right now. This will be available for you guys on our YouTube channel and our website as well by next week. This session 1, the part you guys have, you guys can request for subscription. You will receive an email to subscribe. If you guys want to subscribe, go ahead. Once you subscribe, you will receive the details for the next sessions which will be conducted for this course. So thanks a lot for you guys for your time. And do you guys have any question or queries from me right now? Okay. So right now, what I'll do, I'll stop the recording over here. And thanks a lot once again for you guys. And the session will still be open to take your questions. Thanks a lot.